thank you very much for being here. I want to thank also the organizers of the conference for inviting me. It's the third year I have been here and I love it. Every time it's a new adventure. I get to know great people and I get to talk about the things that I love, that inspire me and make me want to get up in the morning. So today we're going to talk about artificial intelligence, machine learning. It's a topic that it's very much in the news, very much in the talk on all of us. We are not going to talk about the new chat GCP, GCT stuff, but things that are more real for practical applications we can develop, we can integrate into our applications. Let me introduce myself. My name is David Sol. I live in Mexico City with my wife, my daughter, and a couple of rabbits that got graduated from university. I work as an site reliability engineer at Wizeline, a great company. All are welcome. If you are interested, you can contact me and we can talk. We are always looking for talent. I'm very glad that Wizeline is a sponsor of the conference this year, and I hope from now onwards. I'm certified as DevOps engineer professional and database specialty. I'm part of the AWS Community Builders program. I would tell you that program is great. If you have questions about it, please contact me. It's very useful, professionally speaking, and there is a way to get into this program. And you can contact me on Twitter as SolDavidCloud. I promise I answer things there. And I post information about cloud, about Python in that channel. If you want to know me really as a person, I would tell you these three things. My favorite book is The Hitchhiker's Guide to the Galaxy from Douglas Adams. My favorite comic is Planetary. I just learned that there is going to be a movie about The Authority, which is done by the same creative team, Warren Ellis and John Cassaday. So I'm very, very excited about that. And my favorite movie is Flash Gordon from 1980s. When I was a kid, I loved that movie and it's very important for me. I simply love it. If you haven't seen it, don't miss it. Okay, let's start. And please, if you have questions, feel free to interrupt me at any time. To start, I want to define stuff, to be clear what we are talking about. What is artificial intelligence? Artificial intelligence is the use of computers to infer information. Normally, we use computers to capture data, process the data, and get some knowledge. Relate this data and create some kind of information from it. Derive some kind of knowledge. With artificial intelligence, we are pushing the data into the future. We're trying to predict what is going to happen. We are doing inference with this information. And that has some risks because we are trying to guess. We are trying to do a very well-educated guess about the future behavior of our systems or reality and be able to take decisions based on that. And there is a lot of ways of doing that, some of them very simple, some of them very complex. And what is machine learning? Machine learning is a way of doing artificial intelligence. And what we want is to create these algorithms, these programs that let the computer allow the computer to improve the responses. What we want with machine learning is for the computer to guess better over time. We want more data getting into the system and the predictions getting better in time. And that's very important. It shouldn't be something that ends. It's not like I train the computer and I have finished. No, I need to keep training the algorithm. I need to keep capturing more data, learning from that data, and predicting better in the future. It's a job that never ends. Okay, we can do that, and we can do that with data centers. We can do that in our laptops, even if it takes a lot of time. But what we want to discuss here is how can we use the cloud to do this? How can we use the cloud for machine learning and artificial intelligence? I'm talking here about AWS, right? Because it's the technology I am more familiar with. But this is not particular from one cloud provider. This is valid, this exists for all the big cloud providers and many of a specific smaller cloud providers. They all have this in some way or another, with more services or less services, with some characteristics or without them. But what we are going to discuss here, it is valid for all of them. We have three levels, three different kinds of services. The first one is frameworks and infrastructure. It's the most basic one. It's infrastructure as a service. What we're going to get is the ability to get hardware, to get this platform, to get this infrastructure where we can run our machine learning or artificial intelligence workloads. The second kind of services, this second layer, is machine learning services for organizations. And we're going to discuss what the big difference is. And these services, this layer, normally in the cloud providers has a name. In AWS, it's called Amazon Age Maker. Amazon Age Maker is not a service. It's not like S3 or EC2 where you can say it's one thing. No, Amazon Age Maker is a set of services. We are talking about a couple dozen services working together with one brand name. In Google Cloud, for example, it's called Vertex, right? And the third layer, the third kind of services we can use, and one that I find very interesting, is managed AI services. Artificial intelligence services that are managed for us. We don't need to manage the infrastructure. We don't need to manage the service. We can only use it. That sounds somewhat weird, but you're going to see what that means. Okay, let's start with the easiest way, the easiest part, frameworks and infrastructure. In the past, we had the chicken and the egg problem, right? I went to my boss and tell him, I think we can create a workload with machine learning that help us predict, help us control, help us manage our business. And to create this machine learning model, I need this processing power. I need computers, I need graphical processing units, I need hard disk, I need network. I need, we have to tell it, important quantity of resources. We're talking about big money, right? We need a lot of power, a lot of storage. And my boss said, oh, okay, I need you a proof of concept. I need for you to demonstrate that this will help, that this will have a good return on investment. And if you do that, I can give you the money to do it. But the big problem is I needed that money, I need that infrastructure to be able to provide the test, to be able to provide the proof of concept. So I needed the infrastructure to demonstrate it's going to work, and I needed it to work to get the resources for the infrastructure. That was a problem, right? Because it was hard for me to convince my business this was something that we want to invest on. Okay, with the cloud, what we can do is to experiment. We can very quickly ask for the cloud provider to give me this computing power. And we're talking about a couple dozen or a couple hundred computers with big CPUs, with big graphical processing units. We can get a lot of storage, and with S3 and object storage, this storage is very cheap. It's unlimited. We can use it. We can prove that what we are doing works, and then we can destroy it, and we can stop paying for it. In the past, this investment for machine learning or artificial intelligence workloads was big and was permanent. We were going to buy this stuff, and we need to hold this stuff for years. And what happens if today we buy NVIDIA GPUs and tomorrow AMD releases a new Radeon GPU that it's cheaper and it's better? We cannot use it because we already paid for the NVIDIA GPUs. There was a big element of risk of acquiring all of this infrastructure and have to use it for several years. Now with cloud, we can ask for this infrastructure, use it and drop it, and only pay for the time we use it. That allows us to experiment, to create this proof of concepts, to use only what we need, to get the new CPU, the new GPU, the new technology very fast, without being tied up to the infrastructure we already have. Another big advantage of this is we can request for the cloud provider a computer, a virtual computer that already has these frameworks installed. And I have to tell you, I have freaked out a couple of computers trying to install a machine learning framework and configuring the GPU, and I mess up and the operating system stopped working, and I have to start from scratch. I have to format the computer again and install the operating system again. The good thing here is the cloud providers let us get virtual computers that already has one of these frameworks installed, already optimized for the hardware, already working, so we can just get to do our work. We don't need to spend time installing it, configuring it, optimizing it. And that goes for the hardware too. These GPUs, these NVIDIA or AMD GPUs, we can know that the virtual computer already has it, and it's already configured to use it, and it's already optimized to get the most from them. That saves us a lot of time and a lot of effort. That's the big advantage of doing it in the cloud. So, second level. Okay, the first level is we ask for these computers and we can use them. We can do whatever we want with them. The second level is Amazon's Age Maker. What's the purpose of this set of services that AWS is providing us and all the cloud providers is providing us? This is when our machine learning or artificial intelligence needs pass from an individual effort, me trying to prove something, to a team sport. We are talking about companies, big organizations, trying to create a machine learning or artificial intelligence organizational framework. We are talking about security. Security is really important. Security is work number one. How do we guarantee that the data and the algorithms and the people are secure? that we are not losing data, we are not losing information, we are not losing proprietary information. How do we manage the teams? How do I know which person works in which area, with which models, with which data? We need to handle the data ownership and traceability. And this is really important when we are doing this besides the demo, besides the tutorial, and we want to do this professionally in real life. We need to know where the data comes from, who had access to it, how it was manipulated, how it was used. We need to be able to tell the stakeholders, to tell our clients where the data comes from, what happened to it, how was it manipulated, how can we guarantee that the data is correct, that it was properly maintained. The training of the models need to go from, yes, I'm in my computer doing some training, and yes, I leave it running and went for a coffee, to create pipelines. As we create the pipelines for software development, as we create these continuous deployment, continuous integration pipelines, we need to create pipelines for our machine learning training, automating the collection of the data, the processing of the data, the training of the models, the selection of hyperparameters, the testing of the models, the deployment of these models into production. We need to be able to automate all of this. We need to create tests. The tests that have helped us so much in software engineering, they should exist in machine learning too. We need to prove that when we update the model keeps giving good responses, keeps working. And we need to know that over time, if we don't update our models, they are going to degrade. The performance of the model, it's going to drop if we don't update them with new data. We don't keep learning. So we need to automate that thing, even the training and the testing of the model, to make sure it's still working. We need auditing and explainability. We need to be able to tell someone why the model behaved in some way, why the model decided to classify the record in some way, decided to predict some value. It's not enough to say, yes, the model said that this is a risk. We need to be able to explain why the model decided it was a risk. That is really important because it put us in control of the machine learning model. If we don't do that, the machine learning model has control over us, and that shouldn't happen. And finally, talking about organizations, we need to have resource management and cost control. We need to know what resources we are using, why, who is using them, for what reason, and what costs we are incurring. We need to validate that the return on investment on the infrastructure, the storage, and the processes we have work, that we are actually helping the business. And again, it's not something that we do at the start and then forget about it. It's something that keeps happening. We need to keep control over time of this resource allocation. All of these needs of our organization to have these machine learning models in production in a professional way is what this set of services do, is what Age Maker is about, it's what Vertex is about. It's the control of the data, it's the control of the computing resources, it's the testing of the models, it's the deployment of the result of the training, right? It's to keep control of all the life cycle of the machine learning and artificial intelligence workloads we want to create. So as you can see, it's for organizations. This is not much for individuals. The real value of these services is when we are doing this big. Okay, how can I start? When we are talking about infrastructure, you can open a free AWS account and ask for a computer with one of these frameworks installed. I am afraid to say the free tier doesn't cover a lot of resources, of infrastructure resources. But there is another providers that do allow you to use CPUs and GPUs. In the case of SageMaker, in the case of this second layer, machine learning services for organizations, there is a service that is called SageMaker Studio Lab. This is free. You don't need to put your credit card. It gives you access to CPUs and GPUs with a limit, but it lets you work, experiment, learn in a very easy way. It's Studio Lab SageMaker.aws. I would invite you, if you are interested in machine learning, to open an account here. You don't lose anything, you don't need to pay anything, and it's free, free hardware, free software that we can use, right? There is offers from a lot of other providers. Google Colab, for example, many people love it. It's the offer from Google, and you can do great stuff there. And there are a lot of other cloud providers, both big and small, that give us these resources for free. This is something I love from this time and age. They gave us the hardware for free, right? I love that. Okay. And this is the other kind of services I love. This is the other kind of services I find very interesting. And these are the ones I'm going to spend more time talking about. These are managed AI services. Turns out many things we do with machine learning and with artificial intelligence are things that many people are interested in doing. There are no completely different stuff. In fact, we want to do more or less the same than other people. So AWS trained the models. They already set up the infrastructure, created the models, created, trained this model, tested them, and they are allowing us to use them, only to use the result of their effort, right? One of them, for example, which I find fascinating, is AWS Recognition. Recognition is their service for vision, to see things. So recognition let us find things in images or in videos. There are services for videos in recognition. Here, there are some samples. Content moderation. It tells you if an image is contains nudity or contains violence or not. It lets you to see if in two images the same face appears, or you can give them 100 of photographs and ask, give me the photographs where this face appears. And it will check all your photographs and tell you in these photographs, the face you asked me for appears. And it's going to tell you the coordinates, where it appears, and it's going to tell you the certainty that it's true. It will tell you, I think the face appears here, or I'm very certain, and I'm not certain that the face appears here. It gives you face detection and analysis. You put a photograph and it tells you it's male or female, is it smiling or not, does it have glasses or not. Now with the pandemic, it tells you if you have the cover for your mouth or not. It tells you the approximate age. It tells you if it has beard or not, if he has hair or not. You can use this to, one use case was take photographs of a camera in the office and check if people is using the masks or not. Or you can use it to see if there are more women or men in a place. You can use it to create filters and put glasses on people or put them a hat, as it tells you the coordinates of every element, because it does that. Tells you the eyes are here, the mouth is here, the head is here. You can use it to create a filter. There is another service that lets you create labels in an image. It takes an image and tells you what is in the image. Tells you, okay, there is a person here, there is a mountain here, there is a car here, there is a donkey here. It's great. In fact, you can check this service in the free tier, and it's very good for parties. You say, okay, give me a photograph, we put it in recognition, and let's see what it finds. In my case, once doing this, I put my photograph with a friend and said it's going to detect us both male, both in this age range, and the recognition told us there are 3 people in the photograph, and we were like, damn, there is a ghost in the photograph. And turns out in the background, almost invisible, was a third person, very far away in the background. And recognition find this person, tell us in this part there is a person. And we zoomed the image out, and yes, it was right. But 1 second we were worried about the third person in the photograph. You can find custom labels. That is great. Let's say your use case is you fabricate pens, for example, and you want to identify the brand of the pens or the model of the pens. Okay, this is a very specific use case. It's not something AWS has trained recognition for, right? These pens are very specific. You can train, say, recognition. You can give dozens or hundreds of images of your pens with the correct labels, saying this is the green precise B5 pen, and then ask recognition to find the pen in other images. You don't need to set up the infrastructure. You don't need to set up the machine learning algorithm. You don't need to run tests. You only need to give the images to recognition with the correct labels, and they are going to do the rest. That is great. It has text detection. And not only text detection, it lets you find elements in the image. You want to find apples, you want to find some specific words. It does it. Even if the text is skewed, even if the text is partially obscured, the part that it's available, you can see it. And there is a different service that does this better. We are talking about it in a minute. Okay, great. Recognition sounds like a great thing. Sounds like something we can use. How hard is to use recognition in Python? It's really, really easy. This is the only thing you need in Python to use recognition. Okay, you're right. I'm skipping the import Poto3. I'm skipping the opening the connection to AWS with our credentials. And I'm skipping the processing of the response. Here we have a response, which is a JSON object. That includes the different labels it found. It includes the coordinates, and it includes the certainty, the probability of the item. Lance says he do fabricate pens. Yes, you can use this for quality control. For example, you can give them images saying this is the pen as it should look, and this the pen as it shouldn't look. Help me find the pens that are bad, that do not pass the visual inspection. So it's very easy to read an image, send it to recognition, and tell me what did you find there. And you say, okay, David, you put the example, and I look the example very on top. I would like to see the code. Show me the code, right? Yes, we can show you the code, and we will see the code in a minute. In fact, you will see all of the use of these services. There are a dozen of different managed AI services in AWS. Some of them very specific, some of them very global, very general. There is one, for example, that hears stuff and tells you if the sound changes. The idea is to put it in a machine, in a factory when something gets manufactured, and the service is hearing the machine, is hearing the sounds it makes, and if the sound changes, normally means the machine is having some kind of trouble, needs some kind of maintenance, and it tells you, hey, the sound changed. And that's all it does, tell you if the sound changed. Okay, the ones we have in the sample are comprehend. Comprehend is semantic analysis of text. It takes a text in English, this one is only in English, and it tells you what the text is about, what the subject matter is. If the way it's expressing about the subject matter is positive, negative, or neutral, they are talking nicely or are angry, they tell you if there is personal identifiable information in the text. It tells you what sentences the text has, which verbs, which each word, what is it? It tells you the key phrases of the text. So it's really useful to give a quick scheme to a lot of texts and tells you which texts are more positive, more negative, which of those texts talk about a specific subject matter, all of that in a very quick, easy way. We have Amazon Poly. This is great for parties. You put a text, you choose a language, you choose a voice, male, female, neutral, friendly, and it creates you the audio file of the text. How hard is to transform our applications to something someone with that cannot read, cannot see, can use? Very easy, because Poly can transform the text into audio. So even someone with sight difficulties can hear the result of the application. And as in the case of recognition, it's very easy to use. You only need to tell the text, the voice you want to use, and it gives you the audio file very quickly. If you check the AWS blogs, in the top part, it always has the audio transcript. You press play, and it starts telling you the article. It's done with Poly, and we can use it very easily. Transcribe. Transcribe, it's very useful, and what it does is the contrary of Poly. You have the audio file, and it gives you the transcript. It tells you what they say, what is in the audio file. So not only tells you what words were said, if there are several people in the conversation, it tells you which people say something. It tells you in which second each word was uttered, and it tells you the certainty it understands correctly. By the way, many of these services have a different version for medical applications. which is trained with medical terms and medical needs in mind. And we have translate. As the name says, you put the text in Spanish and you can convert it in French, in English, Swahili, whatever you want. Again, very easily, very cheaply, without having to manage anything. And we have a lot of other services. There is a service that takes forms, right? And tells you what the form has and gives you as key value. Name this, last name this, code this, date this. It understands tables, for example, and lets you scan a table and give you the information on the table. Really great. How can we see these services in action? How can we see the code that actually uses it? 1 month ago, I gave a talk about it in IndiePy. You can find the links there. We will post them in the chat in a minute. And in that repository, IndiePy 2023-0214, in GitLab, you find the code. You can run that notebook. It's a Jupyter notebook with all the code you need to see these services in action. And you can change the images, you can change the information you request, you can change the text you put in comprehend and poly in transcribe, in translate, you can change the language, you can change whatever you want, the voice, and you can experiment with them. I'm very happy to say that the free tier of AWS, the things they give you for free when you open an account to test, it's a lot. For example, it gives you 1,000 analysis of images each month. For a proof of concept, for learning, is more than enough. You can use it without the fear of getting some costs. And what the cost is, how much does it cost to analyze an image? To tell you the truth, it costs cents. Normally, it's like 10 cents an image or 10 image for 1 cent, things like that. It's very cheap for a small application, for a proof of concept. Normally, it's free or it's very cheap. If you want to use this in production for a big application that has hundreds or thousands of requests each hour, these can become very expensive. These managed services that are great for testing, that are great for learning, for using them in production, for real, with thousands of users working all the time, they can become expensive. They can become a problem. Finance talking. But for learning and for doing tests, for doing a proof of concept to prove the bosses that this works, they work great. And I would tell you, test them, try them, check the repository. All the code is there. You can see everything you need to use them. And if you have any questions, you can contact me and I will be very happy to help you. So that's everything for now. You need to go to check the repository, test the code, and tell me how it works. And if you have any questions, I will be very happy to answer them.